There's been a lot of debate, and there still is a lot of debate at the moment about what is dyscalculia. What's the definition of dyscalculia? What's your take on that?
So I look at the mathematics learning problems on a continuum. One end of that continuum, I'll say the left one, no politics involved. On the left end of this continuum is mathematics learning problems related to number, related to numeracy. Then a little later, we have mathematics learning problems which are related to mathematical concepts other than numeracy, algebra, or geometry, or higher mathematics. So the numeracy problems alone, and when I say numeracy, I'll divide into three parts: concept of number, number sense, and numeracy. So there are three parts to my definition of dyscalculia. It is a child's difficulty or lack thereof of number conceptualization. Second, number relationships, that means arithmetic facts. And three, the execution of arithmetic operations, that means a child's ability and facility in executing four whole number operations with understanding, with fluency, with ability to able to explain that. So there are three components of that difficulty: that child has not conceptualized number or has not been taught properly. So dyscalculia is a child's difficulty in conceptualizing number relationship, and outcomes of numerical operations. Those three things.
And obviously, it applies to adults as well as just children.
So adults will fall into two other categories. The one is, so I define dyscalculia in two parts. One is innate dyscalculia, where the cause of the problem lies in the child. There might be cognitive factors there. There might be that there was no experiences by which the child could bring out the innate abilities. The second I call is acquired dyscalculia. Acquired dyscalculia means I have all the equipment necessary, I have all the cognitive abilities, I have all the abilities possible, but I was not taught properly. And when it's not taught properly, it's not my fault. It's environmental factor. I didn't have chance to go to school every day, or there were no materials in that classroom, or the teacher was not properly trained, or any of these factors which are outside of me. So I want to differentiate between the innate dyscalculia and acquired dyscalculia. Now adults, there's another element comes into play, which is called acalculia, or early on they had trauma about mathematics. Once I put a questionnaire on my website several years ago: do you have math anxiety? If you have math anxiety, tell us, when did you experience it? When did you start feeling it? What was that moment? So most of the time, when people said they had math anxiety and they were asked when it happens, they could pinpoint exactly when it happened. And I saw a pattern. And the pattern was they were having this difficulty at the transition of a developmental mathematical concept. So first was conceptualization of number. Second was when they were introduced to facts, addition facts or multiplication facts. Third was place value. Fourth was fractions. Fifth was integers. Sixth was transition from arithmetic to algebra. So at these junctions, the transition was not easy. They gave exactly the incident where it happened. One woman, age 54, said, I remember I was in third grade. I was sitting in my school next to the window, and my school was in the rural area. And I was seeing the nearby farms, the cows were in the pasture, and it was a nice day. And I was looking at those cows. I come from a farming family, so I was interested in them. And all of a sudden, teacher asked me, what is 8 times 7 or something like that? And I came out of this reverie and I blurted out some number. And the teacher said, you don't even know this, whatever that fact was. And that was the beginning of my math anxiety. Somebody said, I never really understood why the numbers increase to the right on the number line, but when it comes to place value, ones, tens, hundreds, thousands, they're increasing this way. What is this? Why it's happening? Why it's not ones, tens? So, place value, another development milestone. So there are certain developmental milestones. And when the transition in these developmental milestones does not take place properly, there is a difficulty. Somebody said for the first time, fractions. The teacher said 1/2 times 1/3 is 1/6. And they're smaller than that. Multiplication is supposed to be bigger. How did it get smaller? So every time a new concept begins, in most cases, it creates a cognitive dissonance into this schema you have about things, about numbers, about concepts, about facts. And when that disturbs, if somebody clears it up nicely, there is no problem. But if it doesn't clear, then we begin to have anxiety about it, and therefore mathematics anxiety. So mathematics anxiety itself is of two kinds. One I call as specific mathematics anxiety, and the other is called global mathematics anxiety. The psychologists give it a name of more particular ones, but in my case, in the mathematics case, the two things are specific mathematics anxiety means the person is anxious in a particular aspect of mathematics. And the global mathematics anxiety is when a person is anxious about many things, but it manifests in the areas where the answer has to be correct or wrong. So if you ask a person spellings, there's lots of people have spelling anxiety. And if you start asking, who was the king in the 14th century in such and such area, they will have the king anxiety, and that will be, at the royal level.
It doesn't seem the same magnitude of anxiety in history or spelling than it does in maths.
In reading it could be, but in other areas you can fuzz it, you can go around it, and you can talk a little bit and still not sound as if you don't know. But in the case of those areas where the answers are yes or no, and we make mathematics that way. It doesn't have to be that way, but they make it that way. Either you know 8 times 7 is what, or you don't, and therefore you get anxious when you are wrong. So that's what happens there. So that's another area. Then there is what I call as language-related mathematics difficulties. And that's why 40% of dyslexics also show the symptoms of dyscalculia. So in other words, there is a common area where both things are being processed. And that happens when number became associated with the language. So initially, number is an innate skill. It was an evolutionary skill. It was a skill needed for survival. So it was in the occipital area. But when it got connected, because this thing has to be communicated, I have in front of me a group of predators, and I want to make my family aware that there are so many of them. So names were invented. So the innate skill is subitizing, but it becomes real when counting and language interacts with it. Now when the language interacts with this, the number concept from the occipital area transfers to Wernicke's area and all the other language areas. And when it associates with the language areas, naturally there is an intersection of quantity and language. So many times children have difficulty with mathematics because of the language part. Just to give you an example, if I have a problem, 17 minus 9, and I ask a child to read, and the child reads 17 minus 9, 17 take away 9, 17 subtract 9, 17 deduct 9, and so on and so forth. Those are all direct statements, active voice. But suppose I change it slightly. 9 less than 17 is what? Subtract 9 from 17.
Yeah.
All of a sudden the statement is passive voice now.
Yeah.
It's an indirect statement.
Yeah.
And many times children will say 9 minus 17 rather than 17 minus 9.
Yeah.
Then there's a third level of language there. And the third level of language is, what is the difference between 17 and 9? 17 is how much more than 9? 9 is how much less than 17? When will 9 become 17? How will 9 become 17? So they can give the answer for 17 minus 9, but when it comes to word problems, all of a sudden they will have difficulty. The language is not direct.
Yeah, my students typically really don't understand when you ask them to find the difference. Almost seems like it's not related to the question.
Yes.
For a lot of those children.
Yeah, one is bigger, one is smaller. One has 2 digits, one has 1 digit. So they are looking. So that brings another area. When you look at a word in mathematics, a vocabulary term in mathematics, or a phrase in mathematics, they fall in 5 categories. Those words which have the same meaning on the street and the same meaning in mathematics. Very easy, because you are just, no schema has to be developed. The schema is already there, the usage is already there, and therefore I know it. But there are many words which have a different meaning on the street than the classroom. Those are the second level of difficulty. Third, the words which exist only in mathematics, not anywhere else. They are even harder. Then we have compound words where least common multiple or greatest common factor or simultaneous linear equations, etc., etc. Relatively prime number. So there, the concept becomes even more difficult.
Yeah.
Then we have a 5th level, which is miles per hour, or density, or such and such, such and such. So the language plays a big role in mathematics, and unfortunately, most teachers, most parents do not emphasize the language part of that. So those difficulties, lots of people call that dyscalculia. They can't do math. But it's not. It is language-related mathematics difficulties. So that's why I said continuum. So for me, dyscalculia deals with only with number relationships, and outcomes of numerical operations. Now, an algebra student can have dyscalculia, and therefore his difficulty might be in algebra because of this. But that doesn't mean that, that difficulty we can call as algebraic difficulty. It is not.
Yeah. Okay, thank you for that.